Beyond that, his spectrum went dark. It remained that way for 130 years, until 1801, when German physicist Johann Ritter shone light on this darkness. He knew that silver chloride went black when exposed to visible light. He was now studying whether different colors had different effects. He projected the spectrum onto paper that had been soaked in silver chloride. He marked the end of the visible spectrum and let the paper react to light of different colors. Silver chloride was least sensitive to red light, reacting more strongly as the light became bluer. But the strongest darkening was beyond the violet end of the spectrum. This must be from invisible light beyond the violet, so he called it ultraviolet. We can't see ultraviolet, but photographic paper can, as Ritter demonstrated. And so can the modern chips in digital cameras. The camera makers normally use sophisticated filters to stop UV. But if we remove these and add one that lets only UV through, we can see the world in ultraviolet. Flowers have very different patterns when seen in ultraviolet. Often the petals reflect UV and the centers absorb it, so the center of the flower appears black. But why are these invisible patterns here? Because they're not invisible to insects. Insects can see UV, and the UV patterns on flowers form targets to guide them to the center where the nectar is. As the insect feeds, the flower is pollinated. A garden looks very different when seen through the eyes of a bee. Birds can also see ultraviolet. And this kestrel uses its UV vision to find the best places to hunt. It hunts for mice and voles, and a field is a good place to look. But this field holds no interest for the bird. It soon leaves to find a better one. How did it know there weren't many mice here? This field is better, and the kestrel can tell from 30 meters in the air. Look at the field through the kestrel's eyes. It's splashed with patches of ultraviolet. This is what it was looking for. The UV patches are made by rodents. The urine of voles and mice reflects UV. And the kestrel can see this. By searching for fields with lots of potential prey, the hunting will be easier.